talk about geometric probability. On your notes, you have some information about a dartboard problem where your friend has a dartboard and you get points by hitting the shaded region. So you want to figure out what is the probability that if you throw a dart, it will land in that shaded region. So the first thing you have to do is determine the area of the entire dartboard. If you don't know your basic area formulas, now's a good time to go back and study them. So this one's a square. Squares and rectangles, of course, are both just length times width. So we would do 18 times 18, and we find out that the area of this whole rectangle, or whole square, excuse me, is 324 inches. Next, we have to determine the area of the shaded region. Well, it's a circle. We have no information on it to start with, but you know the formula for a circle is pi r squared. So if you look up here, if we draw a radius over there, you'll notice it's half the length of the bottom of this. So that means our radius is going to be 9. So to get our answer, we would do pi times 9 squared, which gives us 254.34. So what do we do with this information? I know the area of my shaded, I know the area of my whole dartboard. So now, to find the probability of landing in the shaded region, we want to do this. The area of the shaded region divided by the area of the entire dartboard. Or, in some cases, it might ask you for the non-shaded region. And on this dartboard problem, there would be some subtraction involved, but you just have to look at what you're being asked. So in this case, I took my area of my shaded, divided it by the area of the whole thing, and got 0.785, which is between 0 and 1, which is where you want probability to be. And when I make it a percent, it's 78.5%. So you have a 78.5% chance of landing in that shaded region. Now, does this make sense? Well, if you look at the dartboard, it looks about like this, and that shaded region took up most of the dartboard. So to say that we have a 78.5% chance of landing here makes sense because all that's not shaded is these 4 corners. So let's look at another problem. Here I have another dartboard with 2 circles in it. So we want to find the area. This time we're looking for the non-shaded region. So we know we're going to do non-shaded divided by entire area, or entire, we'll call it board because we're still working with the dartboard. So up here I have 2 circles. Well, how do we figure these out? Let's look at 1 circle. So we're going to divide this in 2. So we'll say that that makes this 6 and this 6. So that would make our radius out to here half of 6, or 3. So in this case, our radius will be 3. Alright, so everybody see where I did that? I divided my rectangle in 2 because I wanted to split up the 2 circles, and then my radius, of course, is half of that. Now that I've done this, I know that my radius is going to be 3 in every direction. So that means that my side of my rectangle must also be 3. So now, let's find the area of the non-shaded and divide it by the entire board. Let's do the entire board first. So the whole board is just going to be 12 times 3, which will give us 36. Alright, so to do the non-shaded, I have to do area of a circle 2 times because I have 2 circles. So I'm going to do pi r squared, which gives us, let's see, 9 times pi. Whoops, this is not 3. This is 6 because this is a whole thing across. My bad. Everybody look, this would be 6, not 3. 3 is only half of it. We want that. So this is 12 times 6, which is 72. Now we're correct. So pi r squared, if I did pi times 3 squared, we get 27, or 28.27. Well, remember, there's 2 circles. So I'm going to multiply this times 2. And that gives me 56.55. So up here, I'm going to say that my non-shaded region is 56.55. My shaded region is 72. So what is the probability of landing in the non-shaded? Well, 56.55 divided by 72 is, wow, 0.785. What are the chances? Which again would be 78.5%. Does this make sense? Well, almost the whole board is non-shaded again, just this little bit of area is. So yes, 78.5% does indeed make sense once again. And that's geometric probability.